Welcome, curious minds, to another deep dive. Prepare to have some maybe deeply ingrained assumptions about artificial intelligence challenged today.
That sounds intriguing.
Yeah, you might inherently believe that when it comes to cutting-edge AI, bigger is always better. Massive scale, gargantuan data sets, billions of parameters, that these are the ultimate signs of power and capability.
Right, that's the common perception.
But what if the future of truly impactful high-stakes AI, especially for those critical tasks, the ones underpinning our most complex industries, is actually, well, much, much smaller?
Indeed. It's definitely a counterintuitive idea, isn't it? And it demands a rigorous unpacking. For years, the prevailing narrative has really been singular. More data, more parameters, more compute equals more power and greater intelligence.
Exactly. We hear all the time.
And this has fueled a global race to build ever larger models, leading to some, truly impressive general-purpose AI. No doubt about that. However, the source material we've immersed ourselves in for today's deep dive suggests a profound and potentially revolutionary shift in thinking. It argues that for specific, vital applications, the scaling paradigm might actually be, well, a misdirect.
A misdirection. Okay, so today we're plunging into small open source AI, the future of domain superintelligence. We're not just going to scratch the surface. We're going to really dissect why smaller, highly specialized AI models, particularly those designed to work in unique, collaborative, tag team configurations, are poised to completely revolutionize what we call the knowledge professions.
Right, things like law, medicine, high-stakes finance.
Exactly. Think law, think medicine, think high-stakes financial analysis. Our sources predict this seismic shift could begin as early as 2025 and rapidly accelerate through 2026.
Our mission today is, really, to thoroughly explore how these collaborative clusters of small open-source models can achieve unprecedented levels of accuracy and efficiency. And specifically in the very domains where precision isn't just, a nice-to-have, but an absolute non-negotiable requirement.
Absolutely critical.
We'll show you why a bottom-up approach to AI construction building intelligence from foundational specialized components, rather than, say, attempting to create a single monolithic brain, might just be the key to unlocking the next wave of truly agentic AI.
So less about general conversation.
Right. This isn't about general-purpose tools capable of broad conversation. It's about intensely focused, hyper-accurate intelligence designed to solve specific, complex problems at a superhuman level.
Okay, so what does this all mean for you listening in? Whether you're navigating an information-saturated world, trying to stay ahead in your profession, or maybe just intensely curious about the bleeding edge of technology. If you've ever found yourself wondering how AI could genuinely assist in complex, human-level tasks, the kind that require nuanced analysis, rigorous critical thinking, and absolute reliability,
Which is the hard part.
without costing a fortune or, crucially, making catastrophic mistakes, this deep dive is absolutely for you. We're going to illuminate how a very specific kind of AI is being designed right now to directly address those core challenges of accuracy and critical analysis, delivering those true aha moments of insight that really move the needle in professional fields, perhaps even your own.
It's really about moving beyond simply having access to a vast ocean of information
Right.
to actually applying rigorous, reliable logic and discernment to that information, extracting verifiable truth and actionable insight. That's the goal.
Verifiable truth. Okay, let's unpack this by first acknowledging the current, the dominant landscape. When we talk about cutting-edge AI today, the paradigm that immediately comes to mind often revolves around these truly massive models.
The big ones, yeah.
When our sources refer to O3, 2.5 Pro, or Grok 4, they're referencing the large-scale, general-purpose AI systems you're likely familiar with, the ones with hundreds of billions, maybe even trillions of parameters, often developed by the major tech companies. These models are widely recognized, and they serve incredibly important general purposes. They can summarize articles, draft emails, brainstorm ideas, even write code or creative content. They're impressive.
Undeniably.
The general perception out there, certainly among the public, and maybe even some within the tech world, is that these massive generalized AI models represent the ultimate goal, the pinnacle of AI power and capability. The belief is essentially the bigger the model, the smarter and more capable it becomes across every conceivable task.
That's precisely right. These large models have undeniably captured the public imagination. They demonstrate impressive capabilities across a wide range of general applications, and they've certainly proven to be powerful tools for broad understanding and content generation.
Yeah, they're generalists.
Exactly. They're designed to be generalists, capable of answering questions across a vast array of topics, assisting in myriad general tasks, and providing a baseline of utility that's truly unprecedented. However, what's fascinating here is that our sources present a counterintuitive argument that directly challenges this prevailing wisdom, especially when it comes to high-stakes, specialized applications.
Okay, here's where it gets really interesting. Despite the sheer scale, the astronomical training costs, and the impressive general capabilities of these big monolithic models, our sources argue that what's truly needed to accelerate the 2025-26 agentic AI revolution, particularly for those highly specialized and critical tasks, are actually smaller open-source models.
It's a complete pivot.
It really is a complete pivot in focus from universal generalization to pinpoint specialization.
Yes, and the core advantages are compelling. They strike directly at the heart of efficiency and effectiveness. These smaller, specialized models can do things much better than their larger counterparts in specific defined domains.
Better, okay.
And they can do them at a much lower cost. This immediately highlights their disruptive potential.
Better and cheaper. That's usually a winning combo.
Pretty much. And better here means more accurate, more reliable, and crucially less prone to the hallucinations or logical inconsistencies that plague even the largest general models when faced with truly complex domain-specific challenges.
Right, the making stuff up problem.
Exactly. And lower cost refers to the computational resources required for training, fine-tuning, and ongoing inference, basically, the cost of running the AI day-to-day. This efficiency is absolutely critical for rapid deployment, iteration, and importantly, accessibility.
Right.
Imagine a system that offers superior performance without the exorbitant computational and development expenses often associated with massive AI.
So what does this radical shift in focus mean for you, the listener? It means the barriers to entry for developing and deploying highly effective AI solutions could be dramatically lowered. If small, specialized models can demonstrably outperform larger generalist ones in specific high-value tasks, then the need for multi-billion-dollar compute clusters and vast proprietary datasets becomes, well, less of an absolute necessity for cutting-edge AI development.
That's a big deal.
It is. This could lead to a significant democratization of access to powerful AI tools, allowing a much broader ecosystem of innovators, from nimble startups to smaller research institutions, even individual developers, to contribute, innovate, and compete.
It really opens things up.
It's about agility and focused power, not just brute force. This could profoundly reshape industries, making advanced AI not just a tool for tech giants, but a strategic advantage for any organization willing to embrace this specialized approach.
Exactly. It fundamentally shifts the playing field. Instead of AI innovation being concentrated in the hands of a few, incredibly well-funded entities, it becomes accessible to a broader ecosystem of innovators. And this accessibility, in turn, can lead to more diverse, tailored, and truly groundbreaking solutions that address specific industry needs with unprecedented precision.
Okay, moving on to perhaps the most critical aspect, that these small, specialized models are uniquely positioned to address the accuracy imperative, especially within what we call the knowledge professions.
Yeah, this is key.
When you delve into fields like medicine, law, or high-stakes financial analysis, where decisions can have massive, life-altering, or financially catastrophic consequences, the primary challenge, according to our sources, is unequivocally about accuracy.
It's everything.
It's not just about getting an answer. It's about getting the right answer every single time without ambiguity or error. Consider a medical diagnosis where a misstep can cost a life.
Absolutely.
Or a complex corporate contract where a single misplaced clause can unravel a multi-billion-dollar deal. The stakes are just astronomically high.
And what's crucial to understand here is that there's a common misconception, kind of pervasive false conclusion that our sources address and dismiss directly.
Okay, what's that?
Many people observing the rapid progress of large language models believe that to achieve human-level accuracy in these complex, high-stakes fields, AI would simply require more complete datasets.
Right, just feed it everything.
Essentially, yeah. An AI that has consumed and perfectly indexed every single piece of information ever created on a given topic. The thought is, if it just had all the data, it would automatically be accurate.
Makes intuitive sense, I guess.
It does, but our sources explain why this isn't the true bottleneck. The issue isn't simply the volume of data available to the AI, nor is it about needing to wait for some mythical, perfect future data set.
Okay, so it's not just about more data. What is it then?
Right. It's not about how much raw data the AI has consumed, but rather how it processes, interprets, and applies rigorous logic to that data.
The how.
Exactly.
Yeah.
What's truly fascinating here is that the sources point directly to human experts in these fields as the ultimate model. Think about a top-tier lawyer drafting a complex corporate agreement, a brilliant diagnostician identifying a rare disease, or a seasoned financial analyst evaluating a volatile market. They achieve top-level, highly accurate work with today's datasets.
That's a great point. They don't have magic data.
They don't have access to some future perfectly comprehensive data repository. The reason they succeed is because they skillfully apply sophisticated logic and reasoning. This critical analysis, the ability to discern subtle patterns, draw precise inferences, evaluate nuanced contexts, apply foundational principles to novel situations, and even work effectively with incomplete information is absolutely indispensable for achieving accuracy in these professions.
So it's the thinking, the reasoning.
It's about the quality of thought, not just the quantity of input.
This raises an absolutely critical question for AI development then. How can AI replicate, or maybe more realistically and immediately, assist in this crucial human capacity for critical analysis?
Yeah, how do you build that?
Rather than just acting as a sophisticated data regurgitation or summarization machine. The fundamental challenge isn't merely about finding information, it's about interpreting it correctly, applying complex rules, making sound judgments, and predicting consequences based on rigorous logic.
Precisely. And this is exactly where the limitations of purely data-driven, generalized large models become apparent for high-stakes specific tasks. Their statistical correlations, while powerful for general language tasks, can really fall short when absolute logical precision is required.
Okay.
And it sets the stage for why the small model solution is not just an alternative, but potentially a profoundly superior path forward for domain mastery.
So if the ultimate goal is to imbue AI with this capacity for rigorous logic and reasoning, for truly accurate analysis in narrow high-stakes domains, then we need to talk about a very specific kind of intelligence.
Right.
This brings us to a foundational concept from our sources, artificial narrow domain superintelligence, or ANDSI.
ANDSI.
It's important to clearly define what ANDSI is, because it's not about general intelligence, the kind we envision for, sentient robots or AI that can do everything from writing poetry to solving grand unified physics problems.
Not AGI.
Not AGI. Instead, it's about models designed to achieve superhuman performance at artificial narrow domain superintelligence tasks. Think of it as intelligence that is exponentially powerful, but within a very tightly defined, specialized area, like a laser beam of intellect, rather than a diffused floodlight.
A laser beam, I like that.
Yeah.
To help you truly grasp this concept, the sources provide some concrete, relatable examples that might seem almost whimsical at first glance, but are actually deeply illustrative of the underlying logical capabilities.
Okay, like what?
Imagine an AI that is exceptionally good at solving top-level Sudoku puzzles, not just any Sudoku you might find in a newspaper, but the most devilishly complex ones that require multi-layered logical deduction, constraint satisfaction, backtracking, and foresight.
Okay, super Sudoku.
Right. Or an AI that can perfectly navigate large-scale mazes with absolute precision and efficiency, always finding the optimal path, never getting lost, always reaching the exit.
Interesting examples.
These are examples of narrow, well-defined problems that require specific, rigorous application of logic and problem solving, not broad general knowledge.
And here's the profound aha moment, I think, that connects these seemingly simple examples to the complex reality of the vast majority of knowledge enterprise jobs now done by humans.
Right. How does Sudoku connect to, say, law?
Exactly. The brilliance here is understanding how mastering these narrow logical challenges, even something as seemingly abstract as a maze or a Sudoku, translates directly into tackling incredibly complex professional tasks.
Okay, explain that connection.
Consider how a top-tier lawyer, when drafting a complex corporate contract, isn't just recalling precedents. They're performing a multi-layered logical deduction, much like an expert Sudoku solver. Identifying implicit constraints within clauses, foreseeing potential conflicts between different sections, rigorously testing each clause's interaction with others to ensure absolute legal integrity and enforceability.
It's that constraint satisfaction.
Precisely. Similarly, a financial analyst navigating market data is like an AI optimizing a maze, constantly looking for the most efficient, least risky path to a profitable outcome while avoiding potential pitfalls. The underlying principles of logical deduction, pattern recognition, constraint satisfaction, and strategic planning are surprisingly and powerfully transferable.
So an AI that can master the logic of a Sudoku at a superhuman level has developed a foundational reasoning capability
Yes.
that can then be adapted to other similarly logic-intensive problems within a defined domain.
Okay, that makes sense. So how does this apply to you, the professional, the business leader, or simply the curious observer listening?
It suggests a future where AI might not replace all human work or even entire human jobs as some fear. Instead, it could become incredibly effective at very specific, demanding components of those jobs.
Augmentation, not replacement.
Exactly. For example, it could handle the intricate logical analysis required for a specific type of legal contract, or the precise diagnostic reasoning in a medical case, or the complex scenario planning in financial modeling.
Right, freeing up the humans.
Precisely. This frees up human experts for tasks where broader contextual understanding, creative problem solving, emotional intelligence, client interaction, or ethical considerations remain paramount. It's about intelligent augmentation, not just blanket automation. It's about making human experts more powerful, more efficient, and more focused on the uniquely human aspects of their work.
Okay, to make this concept of ANDSI and the power of small, specialized AI truly concrete, let's pivot to a specific and incredibly high-stakes profession that our sources highlight as a prime candidate for this revolution: the legal profession.
Good example.
And more specifically, the drafting of corporate contracts. This is where the rubber meets the road, where theoretical capabilities translate into real-world economic impact.
It's an excellent example, precisely because it so clearly illustrates the distinction between broad, general AI capabilities and the absolute necessity for narrow, superintelligent precision.
How so?
Think about how AI is currently being used in law. Top broad models like those we mentioned earlier, 2.5 Pro, O3, Grok 4, they're fantastic for understanding the overall landscape of law.
The big picture.
Exactly. They can process vast amounts of legal text, grasp general legal concepts like torts, trusts, divorces, or elder law, and provide a comprehensive overview. They can summarize cases, explain legal principles in general terms, offer insights into various legal domains. They excel at broad search, general information retrieval, even drafting initial generic legal communications. They're valuable for their breadth.
Okay, but then you have the truly specific high-value tasks, the ones that generate immense revenue and carry immense risk for legal firms. Our sources pinpoint drafting the corporate contracts that earn legal firms combined annual revenues in the tens of billions of dollars.
Tens of billions, wow.
Yeah, this isn't about general legal knowledge. It's about incredibly precise, detail-oriented work where a single misplaced comma, an ambiguous phrase, a poorly defined term, or a logical inconsistency can lead to catastrophic financial or legal consequences.
The details matter immensely.
Immensely. We're talking about deals worth hundreds of millions, even billions of dollars that hinge on the watertight nature of these documents. This is precisely where the small, open-source mixture of experts, or MoE models, truly shine.
MoE models.
They're not trying to understand all of law. They're hyper-focused on the exact logic, reasoning, and linguistic precision required for flawless contract drafting and critical legal analysis.
The mission for this ANDSI approach in legal contexts is clear, ambitious, and incredibly challenging. It is to discover the logic and reasoning algorithms necessary to the critical analysis that is indispensable to accurate and trustworthy corporate contracts.
Discovering the algorithms, that sounds fundamental.
It is. This isn't just about pulling template clauses from a database. It's about ensuring every single part of the contract is logically sound, legally enforceable, explicitly designed to prevent future disputes, and strategically aligned with the client's commercial objectives.
Accuracy and trustworthiness.
They are not merely desirable attributes here, they are absolute prerequisites. There's simply no room for error or ambiguity when multi-billion-dollar deals are at stake. This system seeks to encode the very essence of top-tier human legal reasoning.
And this leads us to the why it matters for you, the listener, whether you're a legal professional, a business owner, or an investor. Think about the real-world impact. Corporate contracts are the absolute backbone of countless businesses.
They really are.
From multinational corporations trading globally to small startups securing their first round of funding, they govern everything from mergers and acquisitions to supply chain agreements, intellectual property rights, employment terms, complex commercial partnerships.
The list goes on.
It does. Errors in these documents can be incredibly costly, leading not just to protracted litigation and lost revenue, but also to severe reputational damage, missed market opportunities, and even business failure.
The stakes couldn't be higher.
Highlighting the tens of billions of dollars in revenue underscores the immense economic value at stake and illustrates just how crucial absolute accuracy is. An AI system that can reliably produce such impeccably accurate and strategically sound contracts is not just an efficiency tool.
No.
It's a direct revenue generator, a profound risk mitigator, and a significant competitive differentiator in the legal and business landscapes. Imagine the strategic advantage this offers.
It fundamentally changes the risk profile of commercial operations, moving from a reactive stance of mitigating damage after errors occur to one of proactive, almost predictive error prevention.
That's a profound shift from mitigating damage to actively preventing it. And I imagine for any business leader, that's not just about compliance, but about strategic advantage, about building trust and certainty in every deal. Which leads us to the crucial question. How? How do these small models actually achieve this unprecedented level of accuracy and trustworthiness in something as intricate and high stakes as corporate contract drafting?
Right, the mechanism.
The secret, as our sources reveal in fascinating detail, lies in their ability to work together seamlessly. This is where the concept of a mixture of experts, or MoE configuration, truly comes into its own.
The tag team idea again?
Exactly. It's about different specialized models, each excelling at its specific piece of the puzzle, collaborating in a highly orchestrated fashion to achieve a complex, overarching goal. Think of it not just as an ultimate legal dream team, but as a hyper-efficient, specialized legal assembly line, where each station performs its task with superhuman precision and the output is flawlessly passed to the next.
Yeah, exactly. And our sources break down this synergy in remarkable detail, illustrating for you exactly how these components collaborate. Let's look at the specific illustrative roles they identify within this hypothetical yet highly practical MoE architecture for contract drafting.
Okay, let's break it down. First, you have the Princeton bottom-up knowledge graph. Its core role, the sources say, is to retrieve precedent cases, facts, and legal principles that are relevant to the specific contract being drafted.
The fact checker, basically.
Yeah. Its fundamental function is to ensure that the contracts are grounded in accurate and up-to-date knowledge, essentially, the bedrock of legal truth.
And what makes a bottom-up knowledge graph so exceptionally powerful for this specific task? Well, unlike a large language model that might statistically infer relevance from vast, undifferentiated text,
Right.
a knowledge graph explicitly structures and links legal entities, concepts, and relationships in a hierarchical and interconnected way. It's not just a flat database, it's more like a map of legal knowledge.
Map, okay.
This allows for incredibly precise, fact-based retrieval that minimizes the risk of hallucinations, those confidently wrong outputs, or the retrieval of irrelevant data. It ensures the contract is firmly grounded in established legal precedent, statute, and doctrine. The bottom-up aspect implies that it builds foundational legal truth from granular facts and cases, rather than trying to abstract it from large text corpora. It's like having a dedicated, tireless paralegal who instantly and flawlessly pulls every piece of relevant, verified information, past court decisions, specific statutes, widely accepted legal principles, and their interdependencies with absolute accuracy.
Wow.
This prevents factual errors from the outset, which is just non-negotiable in contract law.
That's a fantastic distinction.
Yeah.
So it's about verifiable knowledge, not just probabilistic inference.
Yeah.
Okay, next we have Sapiens HRM, which our sources suggest stands for Human Reasoning Model.
HRM.
This model handles the relevant logic and reasoning. This isn't just a data processor. This is truly the critical thinking engine of the team.
The brain of the operation.
Kind of, yeah. Its function is to apply complex legal rules and principles to the specific facts and precedents retrieved by the Princeton model. It essentially translates raw legal information into actionable, legally sound conclusions. It's the AI equivalent of the senior lawyer analyzing a case, discerning the legal implications of each clause or scenario, identifying potential conflicts, and determining the precise legal effect of every phrase. It might leverage elements of symbolic AI or formal logic to perform rigorous deduction, ensuring every legal conclusion is provably sound.
Precisely. While Princeton brings the verified facts, Sapiens HRM brings the sophisticated legal brainpower to analyze those facts, apply legal doctrines, and derive logical consequences. Then there's Nemo.
Nemo, like the fish.
Apparently. Nemo's specific role is to generate the natural language that makes the contracts readable, clear, and free of ambiguities. Its function focuses squarely on the output, ensuring human comprehensibility and, crucially, preventing future legal issues that often arise from poorly worded, vague, or open-to-interpretation clauses.
Ah, the language part. This is where the art and the precision of legal drafting truly come into play, right? Why is clear, unambiguous language as crucial as correct legal logic in contracts?
Well, because contracts are ultimately read, interpreted, and acted upon by humans and often by courts in times of dispute.
Right.
If the language is convoluted, vague, inconsistent, or open to multiple interpretations, it becomes a breeding ground for disputes, costly litigation, and unforeseen liabilities, even if the underlying legal logic was initially sound.
So Nemo cleans it all up.
Essentially, Nemo ensures the contract isn't just legally correct, but also perfectly understandable, enforceable, and explicitly watertight to all parties. It navigates the complex balance between legal jargon and plain language to achieve maximum clarity without sacrificing precision.
Okay, crucial. And finally, anchoring this whole operation is R1. What does R1 do?
R1. This model handles the high-level logic and reasoning about the contract's overall structure and strategy. Its function is to act as the overarching architect of the contract, ensuring that all parts work together in a logical and enforceable way.
The architect, so the big picture view.
Exactly. This is the strategic layer, responsible for the holistic integrity of the document. R1 provides the overarching coherence and strategic thinking. It's like the lead partner who conceptualizes the entire contract from a strategic vantage point.
Okay.
Ensuring that all the individual clauses and sections align with the client's broader commercial goals, anticipate potential loopholes, and are legally robust from a holistic standpoint. It ensures enforceability, manages risk by foreseeing potential challenges, and structures the document to achieve the desired legal and business outcomes.
So if we connect this to the bigger picture, it's truly like a highly specialized, perfectly coordinated legal team.
It really is.
With each member, each AI model excelling at their specific critical task, but working as an incredibly tight, efficient, and internally consistent unit. It's a distributed intelligence system designed for hyper-accuracy and strategic foresight, not just general capability.
And the orchestration of these models is as critical as their individual capabilities. Imagine a sophisticated router or gate mechanism that directs specific queries or partial outputs from one model to the most appropriate next expert.
Like a traffic cop for AI tasks?
Sort of, yeah. For instance, the raw legal facts retrieved by Princeton would be seamlessly routed to Sapient for logical analysis. Once Sapient has processed the logical implications, its outputs would be formatted and passed to Nemo for natural language generation. And all of this is overseen by R1, which continuously assesses the evolving contract against the high-level strategic objectives.
What about conflicts? If, say, Sapient and R1 disagree?
That's a good question. The MoE system would likely incorporate a hierarchical validation or consensus mechanism, possibly with R1 having the final say on strategic coherence, or perhaps a loop back for reanalysis. This seamless handoff and iterative refinement is what pushes the accuracy to superhuman levels, far beyond what any single general model could likely achieve.
It's incredible how specific and interdependent each role is, and how they all converge to build a truly robust and reliable output. Okay, now let's get down to the brass tacks, the practicalities, implementing such a system.
Right, the reality check.
Our sources are very clear that this would not be easy. There's no magic wand here, no instant plug-and-play solution.
Definitely not.
They state that it would probably take 6-12 months to put it all together, meaning from initial concept to a deployable, robust system. This adds a crucial layer of realism and context for you, the listener. This isn't an overnight solution.
No, it requires dedicated effort, strategic planning, significant technical expertise, and rigorous testing. The challenges lie in integrating these disparate models, ensuring seamless data flow, and building robust validation layers. It's real engineering work.
And that effort, naturally, comes with a financial investment. The sources detail the cost. Several $100,000 to pay for the high-quality legal data sets, fine-tuning, integration, compliance, ongoing testing, etc.
Several $100,000. Okay, that's not trivial.
No, it's not a trivial sum. It encompasses not just the computational resources, but also the time of legal domain experts to curate and label proprietary data sets, AI engineers for fine-tuning the models on these specific legal nuances, and specialists for ensuring compliance with legal standards and maybe ethical considerations.
But importantly, compare this to the hundreds of millions, even billions, required to train a truly massive foundational model from scratch.
Right, it's orders of magnitude less.
Exactly. This is an investment in highly specific, specialized capabilities. It's like a surgical strike of capital rather than a broad, often inefficient carpet bomb.
But here's where the massive return on investment comes into play, making that upfront cost, while significant, look like, well, potentially a pittance in the grand scheme of things. Our sources explicitly contrast this investment with the tens of billions of dollars in corporate contracts revenue that these models could earn each year.
Tens of billions again. That's the key number.
It really is. This truly underscores the immense economic leverage and disruptive potential of this approach. For investment of hundreds of thousands, a firm could potentially unlock access to or improve efficiency within markets worth tens of billions annually.
That's incredible leverage.
Think about that. A single misplaced comma in a multi-million-dollar deal could cost far more than this entire development budget. So the system isn't just about earning revenue. It's about preventing catastrophic loss.
Risk mitigation is huge.
This kind of ROI is the compelling economic argument that simply cannot be ignored by anyone in these high-stakes knowledge professions. Whether you're a managing partner at a law firm, a CFO overseeing legal spend, or an entrepreneur trying to secure investment, it offers an unprecedented competitive edge in terms of both efficiency and reliability.
It's an undeniable case for hyper-specialization leading to exponential returns. And furthermore, it's important to highlight the inherent flexibility and alternatives within this open-source MoE approach.
Right, it's not just this one setup.
Exactly. The sources emphasize that this specific configuration of Princeton, Sapient, Nemo, and R1 is only one way of constructing such a system. They explicitly mention other powerful open-source models like Sakana's AI Scientist and Mistral's Magistral Small that could be incorporated as additional MoEs or used in different collaborative configurations.
Okay, so it's modular. This speaks to the remarkable modularity and adaptability of the small open-source approach. It's not a rigid proprietary black box that locks you into a single vendor. It's a flexible framework.
Lego bricks for AI.
Kind of. You can swap out components, integrate new advancements, optimize specific submodels, and combine different expert models to suit highly specific needs. Perhaps even tailoring a system for, say, international arbitration contracts versus domestic M&A deals.
That agility is a huge advantage. It allows for rapid iteration, continuous improvement, and the ability to specialize ever more precisely as new open-source models emerge. It means continuous innovation can be integrated with relative ease.
And this raises an important and provocative question for the future of AI and the shifting power dynamics within the entire industry.
Yeah, what does this mean for the big players?
Well, our sources point out that major AI giants, Google, OpenAI, Anthropic, Microsoft, they're certainly not barred from adopting this mixture of experts approach. They possess immense resources, unparalleled talent, and vast data sets to pursue this path if they choose.
They could do this.
They could, in theory, integrate small, specialized MoE systems within their broader AI offerings. However, and this is the critical forecast presented by our sources, if these incumbent giants instead continue to focus primarily on scaling massive models, which has largely been their dominant strategy and investment focus. Thus far, our sources predict a significant and rapid market disruption.
Really?
They state unequivocally that the 2025-26 agentic AI market will be dominated by small startups.
Wow, dominated by startups, not the giants.
That's the prediction. It's a bold prediction, fundamentally challenging the long-held idea that AI dominance will always belong to the biggest players with the most compute and data. It suggests that the race for general intelligence might be a distraction from where the real value and market leadership will emerge in the near term.
And the sources clearly explain why these nimble startups would win this crucial battle for market dominance in high-stakes agentic AI.
Why? What's the edge?
It's because they'd be building the small open-source models that more effectively and inexpensively solve the logic and reasoning-based accuracy challenges that are key to winning the space.
Focus and efficiency.
Exactly. These startups are not burdened by legacy infrastructure or a singular focus on general AGI. Their agility allows them to specialize intensely, leverage the rapidly evolving open-source ecosystem, and directly address the accuracy imperative that the knowledge professions demand. This provides a clear, compelling vision of a potential market disruption, where agility, hyper-specialized accuracy, and cost-effectiveness trump sheer size and generalized capability. In the critical domains of medicine, law, and finance, where precision is king, these specialized AI tag teams are poised to redefine what superintelligence truly means and who delivers it.
So what does this all mean for us as we navigate this rapidly evolving landscape of artificial intelligence?
Yeah.
We've truly unpacked a fascinating and, potentially revolutionary shift.
It feels of one.
A move away from a seemingly endless race for sheer size and computational brute force towards a strategic and highly effective focus on specialized collaborative intelligence. It's about precision, it's about uncompromised accuracy, and it's about groundbreaking efficiency, all delivered by nimble, open-source models working in highly orchestrated concert.
For you, the learner, the professional, or the curious observer, this deep dive really shows that being well-informed about AI means understanding not just its raw power or, the latest flashy general-purpose demo, but also its nuanced applications and the profound economic and strategic forces that are shaping its future. The profound aha here is realizing that true superintelligence in specific critical domains might not come from a single massive all-knowing brain,
Like we often imagine.
but rather from a highly coordinated, specialized team of AI models, each playing its role to perfection, delivering verifiable, trustworthy results.
It's a powerful and potentially transformative idea. And as these parallelized AI teams become incredibly adept at complex, high-stakes tasks like drafting multi-billion-dollar corporate contracts with unparalleled accuracy and efficiency, well, it begs a truly fascinating and perhaps unsettling question.
What's next?
What other intricate human jobs, from highly complex medical diagnosis to groundbreaking scientific discovery, from urban planning to environmental modeling, might be next in line for this kind of tag-team AI transformation?
And perhaps even more profoundly, what does this distributed, highly accurate form of artificial narrow domain superintelligence mean for the very nature of expertise itself, and for human collaboration in our increasingly intelligent world? If an AI team can master a domain at a superhuman level, how does that redefine the role of the human expert? And how might we ourselves learn to collaborate more effectively, seamlessly integrating our unique human strength, our creativity, our empathy, our broad contextual understanding with these emerging forms of narrow yet super powerful intelligence?
Definitely something profound to mull over as you navigate your own deep dives into knowledge and the future of work.